Have you ever wondered if a building could accidentally change the temperature of the city? I know, that sounds strange, but imagine walking down the street and suddenly the sidewalks become extremely hot and the apartment gets flooded with the blinding lights and even parked cars start overheating. Now, imagine finding out the reason is not the weather, but a brand new building. This actually happened in Los Angeles, and the cause was something architect didn't fully expect: reflection. In downtown Los Angeles stands one of the most famous concert halls in the world, the Walt Disney Concert Hall, designed by legendary architect Frank Gehry. When it opened, people were amazed. The building didn't look like a traditional architecture. Instead of straight walls and flat surfaces, it looked like a giant curved sails made from metal. The entire structure was covered in stainless steel panels. From far away, it almost looked like a sculpture, but those beautiful metal surfaces created problems that no one expected. Modern architecture often uses the reflective materials like a glass, steel, polished metal. But why? Because they interact with light. During the day, these materials reflect the sky. At sunset, they glow with the warm colors. At night, they mirror the city lights. Architects love this because buildings stop looking static. They become dynamic, alive, changing every hour of the day. But reflection has a hidden side. Light is energy, and energy doesn't just disappear, it moves. After the concert hall opened, something strange began happening. Residents living nearby started complaining. Some apartments were getting extremely hot during the day. People noticed intense glare coming from the building. The stainless steel panels were reflecting sunlight directly onto nearby buildings. In some places, the reflected light was so strong the temperature increased significantly. Some sidewalks became unusually warm. Drivers reported being blinded by the sunlight bouncing off the facade. At first, people thought it was just an inconvenience, but engineers realized something deeper was happening. To understand the problem, we need to think about how the lights behave. When sunlight hits the reflective surface, it doesn't just bounce randomly. It reflects according to precise angles. That's basic physics. If the surface curved and highly polished, it can concentrate light. The same principle used the mirror or solar concentrators. The stainless steel panels on the concrete hull were slightly curved, which means they acted like giant mirrors. Instead of scattering sunlight, they focused it, and the energy was being redirected into the surrounding city. This created small zones where heat and glare become intense. Essentially, the building was unintentionally acting like a solar reflector. Engineers had to find a solution.
But he cannot just redesign an entire building after it's built.
Instead, they studied which panels cause the strongest reflection. Then they applied the surprisingly simple fix. They modified the surface. Instead of being perfectly polished, the steel panels were treated to make them slightly matte. This reduces the mirror effect, and the panels still looked beautiful. But they no longer reflected sunlight so aggressively. The problem was gradually solved, and the surrounding area returned normal. This story reveals something important. Buildings don't exist in isolation. They interact with their environment: light, wind, heat. Even small design decisions can affect the surrounding city. Architects today study something called microclimate, how buildings influence temperature, airflow, sunlight at the street levels. A structure might look incredible, but if it's overheat, street, or blinds drivers, it creates new urban problems. That's why architecture today combines design with environmental science. Architecture is modern design, experimentation, and sometimes unexpected discoveries. If you want to keep exploring the stories behind the world's most fascinating structures, subscribe to the channel, because every building has a story, but the best ones were built to survive.